Okay, in keeping with our approach, which at this point in the course involves doing pictures and shapes without having to do a lot of calculations. We're going to construct the graph of what we call the toolkit squaring function. We'll see why we call it that, but let's just go ahead and construct it. Now, the construction is fairly simple. We start with a 4x4 square. Well, this means we just draw a square. Do our best to draw a square. And assert that its sides are each 4 units. Now, did I do a good job of that? Because you want to always check your work, okay? You draw a square, you're probably better at it already than I am, but I'm going to check, okay? There's the length of my lower edge, and there's the length of the, I call this the width, call this the height. And it looks like it's a little higher than it is wide, so it's not perfect. I recommend that you're going to draw a lot of squares. Practice. I mean, every time you draw one, just try to get it right, and then check your dimensions. Okay, the height's about right over here. It looks like it gets a little taller over here. And I've got an excuse, but I don't need one. Yeah, I'm looking at the board at kind of an angle. I'm looking at it straight on. I might do a better job, but maybe not. Okay, well, anyhow, there's our 4x4 square. And for this 4x4 square, we put a red dot in the middle of the lower edge. Now, did I get the middle? Is this distance equal to this distance? This distance equal to this distance? Fairly good. Maybe a little too long this way, but that's all right. Now, the better we draw the square, the more accurate our picture is going to be. However, the goal here is to be able to quickly sketch function. Okay, so you want to practice this whole process until you can do it quickly. Okay, well, what I'm going to do now is I'm going to go ahead and draw a vertical line, cuts the square in half. Of course, if I did it, that's too far to the left. Okay, but just illustrates the fact that these things can be a little tricky to draw. I should have started directly above the red dot, but I'm just going to go with what I've got. When you draw, do a better job than I do. Okay, so that's easy enough. Vertical line cuts the square in half. Now, I'm going to draw another vertical line that cuts this rectangle here between the left edge and the center in half. So I'm going to say, well, I ought to be about here. Okay. No, it's not great, but there it is. Then I'm going to draw another dotted line that cuts this rectangle, the rectangle between the line I just drew and the center. We want to cut that in half. Okay, and that's good enough. It's not going to give us a great picture, but I want to illustrate the fact that you don't always get a great picture. Besides, I screwed up here and I wasn't trying to screw up. Okay, still looks kind of okay. Now I'm going to do the same thing on the left. I'm going to divide the interval or the region in between the left edge and the center in half, forming a new rectangle, and then I'm going to cut that rectangle in half. And of course, I could continue this. I could cut this one in half, and then cut that one in half, and cut that one in half. Pretty soon, my lines would be all bunched up, and I wouldn't really be able to cut it in half anymore. But we don't need to do that. To do the basic graph, that's all we need as far as vertical lines. Okay. Now, I'm going to attempt to cut the rectangle in half horizontally. So that ought to be about the halfway point. I'm not going to check it. Let's just see how it works. They say I just drew my fingers together there. And if my fingers moved at the same speed, if the left finger moves at the same speed as my right finger, I get pretty close to the middle. And it looks like I got pretty close to the middle. Okay, now, for most of the functions that we draw, the vertical lines will be just what we have here. Okay, now there's one of our three functions that doesn't even need this vertical line or this one. We'll see that. But for most functions, we're going to draw, those are the vertical lines we draw. Okay, now, horizontal lines we draw can differ from one graph to the other, although there are two that use the scheme that we use here. Okay, so what I do is I think of dividing now the interval from the lower rectangle, because cutting this thing in half with a horizontal line, I have an upper rectangle here and a lower rectangle here. I cut that rectangle in half, the lower of the two rectangles. So cut it in half and go down here. Okay. Then I cut the lower rectangle in half again. Now, this half got a little too close to this line, and so that, this rectangle right here and this rectangle here, and this one's a lot thinner than this one. Try not to do that. Still, I cut now the lower rectangle in half once more. Having not done this with a whole lot of accuracy, I'm going to get a slightly distorted graph, but it'll still be recognized. Okay. Now, well, I'm going to pause the video and write something down, so in a second something will pop up on the screen. Okay, just to reinforce what I just did, I've written down abbreviated instruction for what you do vertically, what you do horizontally. You should take a minute and read these and see if you think this matches what we did vertically and how, and see if what this matches what we did horizontally. Matter of fact, you should stop at this point and draw your own. Now, that's known as active learning. If you just sit back and watch what I do next, you'll learn less. And you get in the habit of sitting back and watching the next step without doing anything, you're going to learn less throughout the course, and you're not going to do as well. It's that simple. It doesn't take long. You slop down a square and attempt to do this using these instructions. Don't even look too much at what I did here. Right now I've kind of obliterated it. So pause right there and see if you can draw it using these instructions. Now, hopefully you've done that. Okay, so one thing I didn't tell you with these instructions is where to start. Okay, so if you need that instruction vertically, you need to start at the right edge and do this. Then you need to start at the left edge and do this. If you start at the right edge and have the distance to the center, in other words, cut it in half, not HAVE, HALVE, cut the distance in half or subdivide the rectangle to the right of center, you divide it in half. Then you take the rectangle between that point and the center, which would be rectangle goes from here to here, 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 and up, and divide that in half. And then you do the same thing on the left. So if you need to review, you really want to master this now. You want to be able to, you will need to come into class next time and do this for credit. It's a quiz. Okay, well, there are going to be 3 of these. So if you know how to do this one, it's not hard to see how to do the others, but you're going to have to know how to do them. Okay, so anyhow, there we have it. Horizontally, we have the distance to the lower edge 4 times. Okay, make a little note here. Clarify, we start at the upper edge and have the distance to the lower edge. So here's half the distance from the upper edge to the lower edge. Here's half the distance from that line to the lower edge. Half the distance from here to the lower edge is here. Half the distance from here to the lower edge is here. all these distances get smaller and smaller as we continue to cut things in half. Okay. Here we start at the right of the left half. And we have the distances to the center. When we start at the right edge, here's the center, half the distance is going to be here. And then from there, half the distance is going to be here. We do that just twice on each side. The horizontal cut, we start up here, we go halfway, that's 1. Halfway, that's 2. Halfway, that's 3. Halfway, that's 4. Okay. Well, there we have it. Now, we're going to locate some points. Okay. First of all, locate points at the upper corners. And at the red dot. Okay, so we're going to locate a point up here. Just put a big X here. Big X here. Big X through the red dot. Okay. Now, you go to the second line, starting from the upper left edge. We're going to go to the second horizontal line and the next vertical line. So we skip a horizontal line, but we go to the next vertical line, and we put a point here. Okay. And then, well, we'll go this way, okay? Then what do? We skip another horizontal line and go to the next vertical line, which is here. We'll put a point here. That gives us 2 new points. Then we go to the red dot. Then we make the other side symmetric with this side. So we see we have an X here, this far to the left of the center line. We'll put an X here, this far to the right of the center line, so that this point is a reflection of this. If the center line is, let's say, a mirror, then this point is a mirror image of this. And then this point here is a mirror image of this. Having done that, we sketch a smooth curve through those points. And that smooth curve will be an approximate parabola. It'd be a pretty good parabola. Okay, so I'm going to write down a rule. I'm not going to make you sit there and watch me write it. So we'll just pause for a second. What I've written here is, well, we from the upper left, we skip a horizontal line, go to the next one, and we move to the next vertical line. Now this edge is a vertical line, so the next vertical line is here. And we make a point. Okay, from that point, we do the same thing. We skip a horizontal line, move to the next vertical line. So we skip this horizontal line and up on this one and move to the next vertical line. There we are. Okay. Then we make our mirror image points. Mirror image through the center line. This point is a mirror image of this. This point is a mirror image of this. There are other ways you can think of that, but there it is. And of course, this point is a mirror image of this, and the red dot is its own mirror image. So that this is a symmetric graph. Okay, so our result is a graph that's symmetric with respect to our vertical line that's supposed to go through the red dot. In my case, it didn't. The graph didn't turn out all that bad anyhow, but if I'd actually gone through these points, it would have looked a little worse. Okay. If you do this correctly, if you do this carefully, you're going to get a very nice parabola. You might have to do it 2 or 3 times, so it only takes about a minute to do it each time. So practice that so you can do it. Now, there's more we can say about this. There are things that we can do with numbers, calculations. But again, the reason we're doing this is not everybody, matter of fact, in a typical pre-calculus class, at least half the class doesn't get the calculations right. Okay, we don't use calculators. We have to understand the calculations to understand the functions.